Good afternoon. Thank you all for coming along. My name is Alan Eldridge. As you can tell from my accent, I don't come from around here. I run the pre-sales team for Tableau down in Australia and New Zealand. And the session that we're going to go through today is designing efficient workbooks, the live on stage version, as opposed to the white paper version. I blog about a lot of this material on my blog, which is this one here, The Last Data Bender. If you've just typed that into your favorite search engine, I think it pops up fairly close to the top. So let's jump into this. So the reason that I originally pulled together a bunch of material around this, and the reason why I was asked to give this presentation is that in the past, I had a lot of conversations that went something like this. Talking to a customer and they're basically saying, my workbook is slow and it's Tableau's fault. So come in here and fix it and make my workbook run faster. There was a lot of material on the internet provided by Tableau, provided by our partners in the community, our Zen masters. In fact, the whole community is absolutely fabulous for sharing information around this. But nobody had ever really started to pull all of this information together into a single resource. So I think it was about 4 years ago, I spat out the first version of this white paper, Best Practices for Designing Efficient Workbooks. It's a bit of a daunting read. It's about 80 pages long. So if you're having trouble sleeping, I highly recommend it to you. But, and everybody sort of says to me, why does it have to be 80 pages long? Well, we cover a lot of material. And so the session today is really designed to take the material from this white paper and compress it down into this presentation and to give you the highlights. So instead of 80 pages, I think we have something like 87 slides for our 60 minutes. So it's going to be a bit of a strap in and let's go through this. So there's a lot of material, but as I said, it's a distillation of this particular workbook, this white paper. So if you want to go into more detail about any of the things that we're talking about today, this would be the appropriate resource. Of course, there'll also be the PowerPoint deck to pull down, which will be available on the TC17 website in the near future. So, like all good presenters, I should give you the abbreviated version of what I'm going to tell you to begin with. And if you go away remembering not much more than this, then I'll probably think of this as a fairly successful presentation. I won't go through each of these in detail, but I think probably the top 2 points are the ones that are critically important for you to have in mind. And that is most of the times that we're having a bad experience with a slow-performing workbook, it's generally related to the design of the dashboard in some way. And so what that means is you can't generally say, don't worry about the performance, I'm just going to build my dashboard and we'll get the design right and then we'll come back and we'll fix performance later. The two things are intrinsically connected, as you'll see as we get into some of the points here. So let's really just work with the data, you need to have performance in front of mind as you're starting to build the workbook. The other point here is that you might think that this only matters if you have a lot of data, but that's not always the case. In fact, there are a couple of examples that I'll give today. One in particular where I have a data set which is only 1,000 records long, but because we're messing around with it in a particular way, we end up with a query that actually takes 20 seconds to run. So this isn't something that's only applicable if you've got millions and millions of records. Of course, at that scale, you need to think more carefully about how you're interacting with your data because it's a multiplying effect. There are no silver bullets. There is no one answer that I can give you to tell you what you need to do. And so for each of your situations, you need to test. And you may need to test a couple of variations to see which one is the right one for your scenario. So the white paper is called Designing Efficient Workbooks, and I guess that begs the question, what do we mean by efficient? So I think there's 3 key factors that you need to consider when we talk about efficiency. Obviously, we want our workbooks to be fast. We want it to open quickly, we want it to respond to interactions quickly, we want to be able to have the calculations. And I guess when we talk about fast, there are going to be two different expectations here too. There's having it truly fast, which is I want all of that work to be completed in the shortest amount of time possible, but there's also the perception of speed or the perception of progress. And a good example of this is when you publish a workbook to Tableau Public, we actually snap an image of that. And while we're actually loading the image, loading the workbook in Tableau Public, we'll display that static image for you. So at least you can see what the dashboard is going to look like once it goes live and becomes interactive. So sometimes we need to trickle feed things back to the end user so that they think that things are happening. So speed is obviously the first one. The second one is we want things to be flexible. So there are times when I can do something very rigid, very hard-coded that will result in a highly performant workbook, but the problem is it only answers that one specific question. And now our workbook is useless for any further discovery or exploration that we want to do. So we need to have a balance, obviously, between hard-coding something purely for efficiency's sake, for speed's sake, as well as flexibility. And then the third point is that it needs to be simple. By this, what we mean is you could write incredibly complex calculation all wrapped up in a single frame. But maybe it makes more sense if you break that out into a number of different related, each of those steps, break them out individually, because that's going to make it much more readable and supportable if, God forbid, you get hit by a truck tomorrow and somebody else has to come along and pick up your workbooks. Are they going to understand what it is that you've actually built in here? So we need to come up with a way of balancing across these 3 points here. Sorry, let me just remember to turn my timer on. So, this brings us back to our point here, which is why is my workbook slow? And this is what we want to all take away from this. How do I answer this question? So let's think a little bit about what has to happen from Tableau's perspective when we request to view a visualization. So I'm inside my browser, I hit Tableau Server, I request a particular visualization. Tableau Server has to load that viz. So first of all, we've been bouncing around in the repository, we find out the workbook that we want, we need to go and grab that out of the repository, load it up, we need to unpack it, find out what queries it needs to run, where do those queries go, are they data extracts, are they live? We need to send those queries to the data source has to execute those queries. If it's a live connection, that could be a data source that could be anything, anywhere in the world. If it's an extract, then we need to hit the extract engine to be able to do that. It's going to return the data back. That will take time depending on how much data we've actually requested back. So if it's a highly granular query, we might get many thousands of rows. Hopefully we aren't writing things that will return millions of rows. Once we've got the data back, we then need to do something called computing the model, which is going to run all the table calculations. It's going to design the layout. So an example would be if we have a scatter plot with labels, depending on how big my screen is, we will selectively suppress the labels. So we need to know which of those labels are going to be drawn. So we need information about the screen size, the window size that we're going to execute in here. We then send that down to the client if we're doing client-side rendering and it needs to render the viz. Otherwise, we need to render the viz on the server, in which case we render it into image tiles and we send them down to... So there's a lot of work that has to happen here. So I have a question for you all. Where in this diagram is the bottleneck? Shout it out. Queries? All of it. The problem can potentially be anywhere. And so the problem then becomes, well, if that's the case, how do I know where I should start looking? So what I want to do is give you a model to take away from here to help you understand this. Because I think if we take all of those steps that we just talked about here and kind of map those back into how we work with the product, there are really 4 layers, I think, that we need to think about. And I'll talk about each of these in more detail. But the presentation layer, the analytics layer, the data layer, and the platform. Now, I've drawn them in this inverted triangle for a reason, and that's because the frequency of occurrence of the problem tends towards the top of the stack, which is good because the ability for us to change the things is greatest at the top of the stack and least. So if you think about the presentation layer, which is about how I build my dashboard and my workbooks, it's much easier for me to change the design of a workbook than it would be at the platform layer for me to add another 64 gig of RAM to my server. So we're going to work through this model here. So finding the problem is the first thing that we need to do. And there are a number of tools that I want you to be aware of as we go through here. How many people here have used the performance recorder? Okay, so that's about 20–25% of the audience. This is the first and most important tool that you'll need to learn. So the performance recorder is under the Help menu inside Tableau Desktop. You can also trigger it on Tableau Server. And the way that it works is you go in there, you say start the performance recording, and you will start interacting with your workbook. Maybe you'll open it at that point if you wanted to get the holistic view. So that's always good practice. Open up a blank Tableau Desktop, turn performance recorder on, then open your workbook and then start interacting with it. What that does is it builds up a trace, and it will give us some data that we can then start to analyze. So it'll produce another Tableau workbook at the end. So when you go back in and say, boom, boom, stop Tableau, stop performance recorder, it will spit out a workbook that looks like this, and it allows us to understand the amount of time spent doing various things. So it could be that we will find that our workbook spends a lot of time in the executing query phase, which means we probably need to think about the analytics and the data tier in here. It could be that we have lots and lots of small queries that are being executed, but they're being executed for some reason in serial, or maybe we're not parallelizing as much as we thought we were going to. And so I've got queries that only take 1 second, but I execute 20 of them, and so it takes 20 seconds for the whole thing to run. Or it could be that I have a problem where it's spending a lot of time in the computing layout phase. The query was actually fairly quick to execute, but because of my post-query calculations, like table calculations, maybe I have pulled back an awful lot of data and I need to work out how to render that. Maybe I've got a very, very dense scatter plot, or I've got a lot of data plotted onto a map. So the computing layout, well, in that case, we need to think about what can we do to reduce the rendering time. The query's fine, don't spend time looking there. I just sort of skipped past this before. This is where you in server, and what you'll also have to do is put a suffix on the URL to get it to turn on the performance metrics. Of course, we have log files, a great resource inside Tableau Desktop. And as of, I think it was Tableau 9 or Tableau 10, these are now JSON files. So the wonderful thing about JSON files is we can pick those up and we can put them into Tableau Desktop. So I could start to analyze these in Tableau Desktop. We also have a tool available called the Tableau Log Viewer. This is, I think you can get this off Git. And what that will allow you to do is it's just a quick and easy front end to use to the log files. But you can start to do things like look for tags like begin query, which will help me find the queries that are being executed, and I can see the actual syntax of the query that's being run, and I can see the timing data that's being logged for this as well. We can also pull log files off the server, so this is done through the web interface. And we would generate a snapshot of the log files, and then we would download them from here. And then with the server log files, again, they'll be JSON files, so you can just pick them up and you can pump them into Tableau Desktop. But we also have another free-to-use tool available on Git called LogShark, and there are some sessions throughout Tableau Conference that will introduce you to LogShark. I think we just launched version 1.2 of LogShark as well, so it's got more and new and shiny things available in it. But this is a great way of looking at the overall server performance to see, well, okay, what are my slow-performing workbooks? So more of a server holistic view, finding the workbooks that have slow load times, and then maybe what we need to do is to look at it and say, do those load times appear at a particular time, or do they always happen? Is it just a generically slow workbook, or is it only slow during particular windows of time? We have a bunch of performance views baked into Tableau server as well. So we can start to look at what are the views that are getting the most traffic from users, what data sources are being used. The one second from the bottom in that list would probably be of real use in this process. So it's our performance of views. And then if you go up another 1, 2, 3 to stats for load times, again, that's also very useful because what it allows us to do is to understand what I want to do is look for workbooks that maybe have a wide variance of load time or just generically have a long load time. If there's a wide variance, we need to start looking at more environmental things. Are there things that are happening at the data tier, or is there network congestion that could be happening to cause those slowdowns? So again, there's lots of good resources in here. We can spin it up, we can start to get information like this. So we can see, this is a view off my demo server that I host at home. Most of my workbooks perform really well. However, I do have some that are in that sort of 5 to 10 second range, which is a little too slow for comfort. We can also start to look at the browser tools. So if you're using, in fact, all browsers have these. This is a snapshot out of Chrome. If you press F12, it opens up the developer pane. One of the things you can do is start to look at the timeline. So in this case here, you can see that big, long green and blue bar toward the bottom down there. That's what we call the bootstrap. So it's the initial package of data that is sent from the Tableau server to the browser in order for the browser to then render it. So it's the chunk of JavaScript that tells it how to render, and it's the data associated with that. So if I'm shipping lots of data down to the client, that could be long. Or maybe I've got a very slow network connection because I'm connecting over 3G, in which case it might just be that it's a slow pipe getting the information down to the browser. On that same front, we might want to take a deeper look. So tools like Fiddler, basically network tracers, allow me to see the traffic that's flowing in and out of the machine, and I could start to, again, make some educated decisions on whether there are network problems associated with my performance rather than something operational within the design of my workbook. We have a tool called Tabmon, which is, again, available through Git. And what this allows us to do is monitor the performance of our Tableau server cluster. So we would use this tool to start to look for things like cache utilization, or we would look at this to understand the overall load being applied to our Tableau server cluster, and we could start to look for bottlenecks, whether it's memory, whether it's CPU. We could start to look for things like, inside Tableau server, we have this thing called the server resource manager that will look for runaway processes that are running hot, and it will kill them and restart them. So if you start to see a lot of VizQL servers being killed and restarted, it's probably an indicator that you've got some resource bottlenecks and you need to maybe think about scaling your server. So, if we come back to this model here, let's have a look at each of these layers in turn and start to talk about them in a little bit more detail. So the first layer is the presentation layer. And at this point, we're really concerned with the dashboards and the worksheets. So this is the kind of the visual layer of our dashboard over here. This is a nice dashboard that we're looking at here. I think it was originally authored by Andy Kriebel, but it's, oh, I've gone past. And so on the surface of it, we look at this and we go, you know, it's a very attractive, visually attractive, elegant dashboard. Why would I have problems with the performance of this particular dashboard? Yeah, so there's lots of sheets on it. So the dashboards are made up of zones. And this is my terminology. This is not a formal Tableau terminology. But these zones are all of the things that are in that red square. So when you start to lay stuff out, it's going to be things like the layout containers and images and web pages and filters and legends and sheets and so on. So all of these zones, we lay them out onto the canvas that is a dashboard. Now some of these zones are going to be data-driven. The obvious one that you would think of is a sheet, a viz itself, but also you need to think about things like filters. So when I grab a filter, if it's an enumerated filter, I need to know what all of those things are. Even if it's a ranged filter, I need to at least know the stop and the end of the range so I can use the slider to zoom backwards and forwards in between. My parameters, they're going to be enumerated. I need to know what those are. Page controls, legends, etc. All of these things that are data-driven need ultimately to get data from an underlying data source, whether they actually reach through and run a query or whether they're fulfilled from the cache. That kind of depends. But you have data-driven ones and static content, non-data driven. Not necessarily static if you think about a web content piece, for example. So the worksheet is the main data-driven zone, and it's made up of a whole bunch of things like headers and panes and captions and field labels and so on in here. And so there's all of these things. Again, the really big thing that we need to think about in here is the main frame, which is going to be made up of a series of marks in here. So each mark is representative of a piece of data that's come back into the result set. And remember that the result sets are generally going to be aggregated when we run our queries against an underlying data source. So in this case here, the marks are the actual stacks of the bars, not the individual, not the accumulated bar itself, but each one of those stacks on those bars is a mark. So let's talk about some best practices when we're putting our worksheets together. The first and foremost is just keep your worksheets simple. One of the things that I see very, very frequently is people will build great big crosstabs because they've come to Tableau probably from working inside Excel, and it's a framework that they're familiar with. Don't get me wrong, crosstabs have their place. What don't have a place is a crosstab that is 50 columns wide and 2,000 rows deep. If you're creating something that looks like that, you are not creating something for a human to consume. You are creating something which is basically a data pump. And so I strongly urge you to really think about when you work with a crosstab, each one of those cells represents a mark, and each one of those marks has to come from an underlying data source. So don't retrieve data that you don't need, and don't render data that you can't see, are the two critical pieces here. The more you adhere to those two pieces of advice, the more performant your workbook will be, because essentially it's having to do less work. Sometimes it's not apparent to you how many marks you're actually rendering. So when you look at a workbook in Tableau Desktop, when you look at a sheet, in the status bar in the bottom left-hand corner, there's always a thing that tells you how many marks, how many rows and how many marks are being rendered. So have a look at that down there and try and keep that number as low as possible. The second thing to understand is that not all marks are the same. And so polygon marks, so again, this is a beautiful dashboard, but pretty much anything that involves curved lines that isn't a native pie chart in Tableau requires us to effectively draw that shape. So a polygon mark, like each one of these wedges is on this starburst chart here, each one of those polygons requires us to generate, well, it would be at least 4, because I need 4 to trace a square, and it'll be more because these have curved edges, so we're doing some interpolation in here. We're probably using either a scaffolding or a densification trick in order to be able to do this. These are expensive. We're making more data for the system to have to process in here. And so these are beautiful, and I'm not saying don't do them. What I'm saying is, as soon as you do this stuff, understand that you have made a conscious decision to go down a path that is going to cost you more. This is a more expensive process. So things like donuts, things like Sankey diagrams, any of those charts you've seen with a curved line like a sigmoid curve in here. These all require us to do additional computation and processing to generate that stuff. The other thing is maps. If you don't need to plot something on a map, and maps aren't always the solution to a spatial problem. If I want to know what is the, postcode that has the most number of subscribers in it, plotting all of my postcodes on a map and looking for the one with the darkest color or the biggest dot is probably going to be a less than optimal approach. What I really want to do is just get a list of postcodes, the number of subscribers, and I want to sort that list. That will answer the question more effectively. So don't use maps if you don't need them. They can be a computationally expensive process. You also need to factor in time for the tiles to load into the background. So when we talk about these zones, interacting with these zones can trigger events. Now that could be something like applying a filter, it could be changing a parameter, it could be an action, like I highlight something. So when I do these actions, when I interact with these things, these events will cause other zones to update. So we know that, when I change a filter, if it's applied across multiple sheets, I can have the whole dashboard respond to the change of that filter. And so we need to, again, understand the scope of impact that this can have. So if I go back to that previous dashboard that we were looking at before, one of the things that we want to do is minimize the number of zones, because effectively each one of these data-driven zones is a query. Now again, not all of them reach through to the underlying data source. Some of them are going to be serviced from cache. But effectively you need to think of it and say, well, each one of these data-driven zones is going to be a query. And so when I think about my filter on the side over here, I need to understand the complexity of that. One of the things we need to do, even just on the filter here, is to understand that some of these zones can be more complex than others. So on worksheets, we've already talked about that. Keep these as simple as possible. Minimize the number of marks that we're displaying in here. But if you've got a filter, and it's an enumerated type filter, so a drop-down list, or a radio button list, or even a single value drop-down in here, could be a parameter. If you have a large list of values, and I'm talking hundreds to thousands at this point here, then we have to ship all of that data. From when we're using client-side rendering, all of that is part of the bootstrap. It's all part of the data package that has to go to the client, because we render that stuff on the client. So again, if you've got really, really large selector lists like this, quite frankly, I don't think these are effective. I think you really need to start using things like a wildcard match or a wildcard selector in here, because then we will only bring back small chunks of the list, not the entire list in here. The other thing to avoid are high-resolution images, because again, they're just heavy content that has to get pushed down to the client. So you've got to minimize the scope and impact of updates. I was talking about this before. So you'll see me saying avoid. I don't mean avoid completely. I guess what I mean by this is be consciously aware of the fact that if you choose to do this, you're making a decision that is more expensive than something else. And so a global filter is going to be more expensive than a local filter. So if we come back to this dashboard before, that's a beautiful dashboard. We have a filter at the top up here. If I change that filter on this dashboard, this is the impact of that filter. So there are two other filters that have a show relevant values, and then each one of these little tuples, so the bar chart and then the line chart associated with that, each one of those is a separate sheet, and so they need to then be rendered. So there's 1, 2, 3, 4 in each one of those vertical stacks in here. And then there's 4 across, so that's 16, 18. So there's like 20 queries that potentially need to fire when we change that drop-down filter. This comes back to something that I talked about earlier, which is that the design and the performance are intrinsically related. I can't get this layout unless I build the dashboard this way. I could represent this same data in a more efficient way, and when I say efficient here, I mean from a processing and querying perspective, because I could probably get all of those line charts, if I put them together into a small multiple viz, I could get them all back at once with one query, and similarly with the bullet charts as well. But because I've chosen this particular layout process, the layout drives the performance. I've forced everything to be broken up. That means I get 20 queries instead of 2. Does that make sense? All right. The other thing that we want to do is try and maximize the effectiveness of our caches. You've heard me mention caching on a number of occasions here. One of the most simple things that you can do to maximize your utilization of the cache is to set your dashboards and your stories to have a fixed size. And you can get this data from the logs. I'm actually querying it out of the HTTP referrer table, which is in the Tableau repository. And when you query that, and in this case here, I'm looking for something that says size, I'm just doing a wildcard match, I can see all of the requests that are going back to my VizQL servers, and I can start to look at this. So maybe I could pull this data out and then start to analyze this and try and identify what my common screen sizes are, and then build my dashboard to service those screen sizes, set it to be fixed. When I set it to be automatic, there are a number of caches that I won't be able to reuse, even if my viz, we're both looking at the same viz, but my screen is like 1 pixel bigger than yours. I get a miss, and I have to rebuild all of the caches specifically for me. And that's driven mostly by, I talked earlier on about that thing called the model. So the model is related to the window size. So on this point of caching, there are lots and lots of caches that exist inside Tableau. So this is kind of a somewhat simplified diagram, if you can believe it, that sort of talks about the caches that exist inside Tableau server. So there's some stuff that happens within the browser. There's a number of caches that exist within the VizQL server. We also then have what's called the external query cache. So we have a native query cache, an abstract query cache. You can think of data extracts as some form of query as well. I mentioned before this thing called the bootstrap, which is the initial chunk of information that we fire down the pipe to people when they ask to view a viz. Again, that bootstrap cache is something that's going to be fixed to the window size. So if my window size is different to yours, I can't use your bootstrap in here. So there's lots and lots of caching that we can leverage, and Tableau is smart and it will use it as much as it can, but we need to work with Tableau and give it a good chance of leveraging those caches as much as possible, because the more often we hit the cache, the less deep in the stack of processing we need to go in order to service the question. The other thing that I just wanted to take a quick sidebar on was this concept of query optimization. So Tableau is very clever, and it's going to do its best to try and reduce the number of queries and the complexity of the queries that it has to run. So we have this concept of something called an abstract query. And what that means is we essentially compile the query statements. And it could be that we have two queries that are actually different from one another, but I can get the result of this from the result of that over here. So maybe this one was a superset of this other one over here. Maybe this query was, give me all of the sales by country and city. Give me sum of sales by country and city. And this one over here is just, I need the sum of sales by country. Well, I can service that from this one by simply aggregating the result set records of the cities within the countries, because sum is an aggregable. So we'll try and do as much of this as we can through these optimizations. We'll run queries in parallel. We'll try and recognize when we can eliminate a query. If we do it, that one, then I don't need this one because I get the results back. And Tableau does a bunch of work to try and find the optimal sequence of events. We do some things called constant folding, so that if you have things that evaluate to a constant value, we only compute it once. We don't have to compute it multiple times. So, I said it before and I'll say it again. Poor dashboard design is the most common cause of poor dashboard performance, and so you really need to have this front of mind when you're going through this. The fortunate thing about this is it is the most easy thing to fix and avoid in future. So a big part of what I want to try and get across to you is the education that not all things are the same, and design decisions have an impact. So I want to give you an example here. I can't demo and talk at the same time, so let me just run this little video here. So this is a dashboard. I'm sure many of you have created a dashboard that looks something like this. A bunch of selector filters across the top, and what I'm trying to do is, I'm drilling down in here through the United States, now through Washington. I'm going to pick Seattle. Then I get the list of all of the manufacturers that come through here. So you can see it's also not a great user experience because these are all related filters, and so every time I flip these filters on and off, they blank out and so on. So what I've done here, though, is gone through, I need to pick the United States, Washington, Seattle, Fabricam, I grab camcorders, and then I pick Q1 of 2008, right? So I did all of this on this particular workbook, and I ran a trace on that. Just for that little video, it ran 203 queries, and if you take all the time that those queries took to execute and just added that up linearly, it took 19.7 seconds of effectively database compute time in order to do that. And the reason for that is there's a bunch of inefficient queries. We'll talk a little bit more about that, but there's a lot of stuff going on under the covers just based on the design of the dashboard. Let me show you an alternative layout that shows us the same stuff. And again, I'll play this little video over here. So this time I'm using something that we call guided analysis. So you can see here, select on the country, select on the state, select Seattle. Here's the list of my manufacturers. I'll choose Fabricam. I'm going to come across here. I'll choose camcorders. From there, I've got an action which allows me to drill to a different dashboard that shows me these two. And now I can start to select that particular quarter. Couple of things about that process. Notice that one of the advantages that I have through guided analysis is that I actually have the context of each one of those selections that I'm making. So you could see when I chose camcorders, they were a significant outlier in terms of sales compared to all of the other subcategories. So I'm able to communicate context with this as well. The other fantastic thing about taking this approach here is that it only required 28 queries and 3.6 seconds. So there's a significant difference in the load that's being applied to the platform and the amount of how reactive the system is. Now again, this is a slightly Mickey Mouse example because what I didn't want to do was to run this over a large data set. I think this was running over about 3 million records and it was running locally, so it was fairly fast. But if you scale the data up at this point, the first design becomes increasingly less efficient. All right, so that's the presentation layer. Let's take it down to the next layer here. Let's start to talk about analytics. So the analytics layer is concerned with effectively the data model that we've constructed here. So it's concerned with, what are those data elements that we're pulling back? We're interested in things like the filters that we've defined when we're building calculations to make sure that we're building efficient calculations. And it also determines how we then start to work across different data sources. So it's going to incorporate things like blending, for example. First thing I want to talk about are the data elements in here. And you probably are aware that in Tableau, you can change the type of a piece of data. So you might have something which is in your underlying data source being read through as a string, but it's really a number, so you can cast it between these data types in here. Well, when you do this, what we're effectively constructing in the query that goes to the data source is a cast or a convert statement. So we're just forcing the database to do more work. So again, where possible, we should minimize the data type manipulation that we're doing in Tableau by making sure that we feed Tableau with an optimal set of data. So if we have the ability to go back and ask our data analysts to redesign that table and have that field natively as a number instead of as a string, then we can take advantage of that. The other thing to really understand here is filters. Hopefully you're all somewhat familiar with the idea that Tableau has effectively an order of operations. It has a calculation pipeline. That's what this diagram is showing us here. At different stages of this pipeline, different things happen, and some of those things are passed through to the database, and some of those things happen inside Tableau. Particularly with filters, we need to understand that there are filters that occur at multiple places, and in many of those cases, there are also different types of filters that we could apply that, again, if we use them carelessly, can result in poor performance. I want to dispel one quick myth. For those of you who've been around the Tableau family for a long enough time, you might remember that in the past, context filters were always considered a big red flag. Use them very much with caution. And the reason for that was because in the past, we used to generate temp tables. So when you had a context filter, we would run a query, spit that out into a temp table, and then run the rest of the stuff over the temp table. And the problem was if you changed your context, then you would have to drop and rebuild the temp table. That doesn't happen anymore. We don't do that anymore, except in some very edge cases. We now almost exclusively use subqueries to define context filters, so they work much better, particularly in MPP, massively parallel processing database platforms, which was a real bugbear in the past. So if you are new to Tableau, ignore everything I just said, use contexts and be happy with that. If you've been around for a long time, forget about the old cautions that you used to have and feel free to embrace the context filter. It is a beautiful thing. And you're going to need them if you're playing around with level of detail calculations anyway. So there's lots and lots of different types of filters in here, discrete versus ranged, and whether they're enumerated or non-enumerated, whether it's within a single data source or whether it's across data sources. And so the trick here is to always think about what you're trying to do and pick the most appropriate filter. So let me give you an example here. Here's a map of Australia, and I'm plotting on this a bunch of statistical areas, centroids, so it doesn't really matter what they are. I've got a bunch of points, and you can see that I'm color coding them based on the state that they're in over here. So the challenge that I have here is I would like to only keep the data points that are in Western Australia, which is the bit which is on the left-hand side, left for you, and it's the brown dots, okay? So all of the brown dots are the ones that are in Western Australia. Now, there's a variety of different ways that I could express this filter. So, for example, I could lasso around all of the, carefully lasso around all of those brown dots and say keep only. But if I do that, what I actually create is an enumerated list of those points. And so I end up with this great big enumerated filter, which again, if you think about what happens at the data level, is going to be a where in massive big list. And that is going to be expensive for the database to compute. Well, the other option would be, and fortunately Western Australia works nicely for this, I could just say, well, I want between the longitude of here, and I would treat that as a ranged filter. Now that will be more efficient because in the underlying query we just say where longitude is greater than this and longitude is less than this. So that becomes a more efficient way of querying it. But remember, going back to flexible and easy or simple, I wouldn't call this either of those two things. The most efficient way to do this would obviously be to just say where state equals Western Australia, and we apply the filter on the appropriate dimension in here. So all three of these filters will produce the same output, but I think only one of these I think we would really call efficient. Again, does that make sense? Cool. How many people here use show relevant values? How many people here use show relevant values a lot? Stop it. Look, show relevant values is great. It's very powerful and it has its place, like everything inside Tableau. But the important thing is you should be using it sparingly. What you shouldn't be doing is using it like I did in the little video that I played back earlier on, where I have lots of things attached to that. Because every time I change something, I basically need to go back to the database and requery the domain of that particular filter object. And what's even worse is many of these queries that get triggered as a result of show relevant values are very expensive queries, particularly if you're working across a star schema or a snowflake schema, because we will typically have to join through the facts table for every single one of those queries. And so you're generating queries that are going to be difficult. They also really reduce your ability to do something called join culling, which is where we drop tables out of the data model that we don't explicitly need in here. So again, use it, be aware of the fact that it is an expensive choice to make. One of the really clever approaches, and I forget whose blog it was that was promoting this technique, but it's really clever, which is where you can take, because we now have source filtering, you can take the filters and point the filters to a bunch of smaller dimension tables, just independent data sources, and then they don't have to run through the fact table because they're just nice and small, but you would then do a cross-database join to link that back to your analytic data set. So there's some blogs out there about using like reference tables and dimension tables directly for these filters. So go and have a look at that. The other thing too is that if you're using row-level security, so if you're using username or is member of, or if you're using the create user filter under the server menu in here, as soon as you do any of that kind of stuff, you can no longer share cache with anybody else. You can share cache with yourself, so if you ask the same question twice, you could hit the cache for yourself. But if I ask a question and you ask exactly the same question, even if you have exactly the same security memberships that I do, we will not share cache with you. And so you need to understand that as soon as you start playing around with stuff like this, you will dramatically affect the effectiveness of your cache, and that can reduce the scalability of your Tableau server deployment as well. So again, use this sparingly. Don't just turn it on willy-nilly. When we talk about filtering, filters reduce the result set. They're different to zooming. So when you zoom in, particularly on something like a map, the rest of the stuff is still there. It's just outside the viewport. So we won't render it, but it's still part of the compute and query that we need to run. So always have a look at that thing in the bottom left-hand corner to tell you how many marks you're actually dealing with. Now there's lots of different types of calculations too. So you need to be aware of the different types of calculations, whether they're row level, aggregate, table calculations. Some of these are passed to the database, so row level, aggregate, and level of detail all get passed through as part of the query. Table calcs happen afterwards. We also then have calculations that we can do by passing stuff out to R or Python or MATLAB. And so when we do that, we need to take the frame of data and we need to serialize it out. It does its computation and then it sends us the answers back again. That transfer to and fro can be slow. And you don't want to do more of that than you need to. So one of the things that you want to make sure you do is select the correct compute using so that you don't inadvertently chunk it up into lots of small fragmented calls. Just some basic physics here. Numbers are fast. They're faster than dates, they're faster than Booleans, and they're much, much faster than strings. So always be careful about doing string calculations over large volumes of data because they are typically an order of magnitude slower than number calculations. Just be aware of other things too, like count distinct it's an expensive aggregate. Level of detail expressions get pushed down into the database typically as subqueries. So again, if you've got very large volumes of data, one of the things that you might want to think about is whether or not you use a level of detail calculation. Most level of detail calculations could potentially be replaced by a table calc. And if you go to my blog, which was blog.databender.net, I have a number of posts and there's a white paper on level of detail and how they sort of can be represented by other types of calculations as well. The ATTR function, again, people will just blindly use the ATTR function. Be aware that, so what it does is it says, if min of whatever and max of whatever equal the same thing, then show me that thing, otherwise give me a star. So I have to do a min and a max. If I know the data is not going to change over the partition, just use one of them. Just use min or max. I don't care which one, don't use both. Here's another example. I actually threw this one in at the last minute because I had a gentleman come to me at Tableau Doctor yesterday for this. So he had a calculation that looked something like this. He had a parameter, and it's so like a dynamically selected measure. And depending on whether I choose A, B, or C, I'm going to show a different measure coming back. Now the problem with, well, not the problem, but again, be aware of the fact that we evaluate all of these. We do not prune the decision tree before we go to the database. So that calculation right there causes this query. And what you can see is it's going to get the sum of sales, the min of sales quantity, the count of sales quantity, the sum of the fact sales, the min of the sales quantity, yeah, and then notice I get count and sum of discount quantity. I actually asked for average. In many cases, when we get asked for average, we'll actually pull the sum and the count because those are actually fully additive measures. If I pulled back the average, I wouldn't then be able to sum them, so I get minimal reuse of the query cache. But if I pull back the count and the sum, I can always determine the average. Plus, I've now got the count and the sum, and I can use them for other problems as well. And I don't have to go back if I ask for an average at a higher level. So again, we do clever stuff inside Tableau. Now, the reason his problem was really bad is because his query looked like this. And so what it meant was we evaluate all of that, irrespective of what his parameter choice was. Now, on the upside, as soon as when you come and then start to change the parameter, it's really fast, right? Because you've already got the answers. But the first touch was terrible. Where possible, use the native features over calculations. So we have groups, we have sets, we have bins. So many of these are going to operate more efficiently than a typed calculation, so leverage them wherever you possibly can. Now, sometimes you can't. So for example, if any of you were at my presentation this morning, one of the things I was doing with the data is I was binning it, but I had to do it with a calculation because you can't reference the bin object in a further calculation. But if I didn't need to do that, then the bin would have been the best way to go. You also need to make sure that you're writing your calculations efficiently, and there are some scenarios where we can get what we call calculation explosion. A whole bunch of stuff happens. Basically, we call the same function many, many, many times through multiple levels of recursion. So what basically happens here, here's the example. We've got 1,000 records in a text table, and what we're pulling back is, these are Minecraft servers. So some of them actually have a domain name, you know, minecraft.allen.com, but some of them have an actual hard-coded IP address, 192.168. And what we wanted to be able to do was calculate the proportion of IP addresses versus domain names. That's that bar in the bottom down there. Now, the inefficient way of doing this was to say, well, what we'll do is we'll say, is it a valid IP? Well, it's a valid IP if it's got 4 address segments, and those 4 address segments are numbers. So address segment 1, address segment 2. Well, address segment 5 has this remove protocol import. Notice that same function is being called multiple times in here. And then it in turn, so we've got all of these things that are kind of layered one on top of the other, and they all call this, and then that calls this thing over here. And so what happens is, in the end, you have this address remove protocol being called thousands of times in order to determine these calculations in here. It explodes, and you end up with a very, very inefficient way. A better way of doing this is to leverage something like regex, for example. So we're using regex to parse that. So we had a 5 and a 4 and a 3 and a 2 and a 1. All of these are just calling regex. They're calling that other function one time. That function calls regex one time. It's a much, much simpler process. There's no multiple calling of the same calculation over and over again. And so what that means from a performance perspective, the pane below shows the slow approach, and you can see it takes 20 seconds against 1,000 records. That's tiny. But when we fix it up and do it fast, it took under a second to run. When we blend, for example, be aware that blending wasn't really designed to work across highly granular data, so don't blend on high cardinality dimensions in here. If you find yourself doing that, maybe think about a cross-database join instead. We have these things called primary groups and aliases that allow us to eliminate blending if all you're doing is blending to pick up a label of some form. All right, so let's push down to the next level. Let's go down to the data level. So now at this point here, we're concerned with the connection. We're concerned with the way we describe the model in here and things like extracts. So kind of getting faster because my timer tells me I'm running out of time. So there's lots and lots of different types of connections. Not all of them are going to be created equal. You need to think about the differences between embedded versus published. One of the things to understand is that embedded visualizations, particularly extracts, embedded extracts will sometimes be faster than extracts that are published through the data server. The reason for this is we have these things called acceleration views, which we use in that show relevant values. We can do that when we're embedded because we understand how those are going to work. We have the context of the use of the extract. When we publish it to the data server, it could be used in anything. We don't have the context, so we can't build these acceleration views. So there are some differences in how things work, whether it's a direct connection or whether we're using the query bridge if we're working inside Tableau online. Again, you just need to think about the differences and consider how many hops need to happen in order to get us to our underlying data source. Having your data in one, so Tableau can do amazing things with data. We can do all kinds of interesting data prep on the fly, but having your data in one place is so much better than having to pull it across a number of different data sources. So whether I'm doing a cross-database join, whether I'm doing a blend, whether I'm doing some other kind of data integration technique, all of these things will be slower than a single query fired to a single database allowing me to join across those tables in here. So the fact that we can do all kinds of interesting data prep does not mean that a good data strategy is applicable. You got to tune your database. Oh, come on, it's like 8:30 in the morning for me, so cut me some slack. So again, we're now starting to, remember I talked about changeability, we're getting down into the harder to change section in here, but these are the things that are going to be relevant for really big data volumes, right? So you need to make sure that you've got indexes. You need to make sure that you don't define your columns as nullable, because when you do, when we join them, we have to do something called a null safe join as opposed to just a straight up join between the two tables. So again, these probably aren't going to be materially important if you're scratching around with small data sources, but when you get into the bigger ones, it becomes really important. Referential integrity, how the tables know about each other. That becomes really important because that's foundational to join culling, which means we can drop tables from our queries. You've got to trust Tableau to do its job. How many people here use custom SQL? Right, so again, it's not a bad thing, but you just have to be really careful with it. How many people here, when they use custom SQL, make sure that they push it into an extract and don't use live connections? Right, that's the best practice, right? But let me tell you a little story. So I was working with a customer the other day. They had a workbook that took about 5 minutes to open. When I looked at it, it was a fairly simple workbook, but okay, let's have a look at the data source. This was the data source. Custom SQL query. All right, let's crack that sucker open and see what we've got inside. So it's not the most beautiful piece, and they had a live connection. So every time they opened their workbook, we needed to run this in its entirety, probably multiple times, sub-selecting stuff off the top. So what we did was we actually sat down with them. So it took about 5 minutes to open. We sat with them, we understood what that data was, what that query statement was trying to do. We rebuilt that as a native model inside Tableau, and we took the logic and we put it into a couple of calculated fields. And just by doing that, I mean, when I say just, it took us half a day to do it, but once we'd worked out all of the logic and we'd remapped it like this, that workbook opened in under 10 seconds. So it's a massive change, right? Now, normally we would just say use an extract. They had big data volumes, they were changing frequently, they needed a live connection, so reworking it away from a custom SQL statement was the trick in here. The less you have to manipulate the data, obviously, the faster it's going to be. So if you're doing unions, if you're doing pivots, if you're running calculations, obviously these things take more computational effort than just reading a native field. So make sure that the data matches the kind of questions that you're trying to ask. And use the data server for governance in here. So have people who know about the data build the data models, and then the people who know about the questions can come along and just focus on building the reports in here. And there are other sessions that will talk about this in more detail, but use this idea of multiple connections. If you've got very large data and you need different levels of aggregation, Think about using aggregated extracts at a high level, and then a data warehouse, and then your sort of a Hadoop data lake right at the very bottom down here. Have multiple connections and actions between them. Extracts are an easy way to make things go fast, but when you do it, don't just blindly turn extracts on. Think about using aggregated extracts. Think about filtering and sampling in here. And understand that when you use extracts, we can materialize calculations if they are row-level calculations. So there's a lot of things that we can think about when we turn extracts on, so we need to use them wisely. Again, there's a whole section in the white paper about this. If we're talking about extracts, we need to think about hyper. It's coming along the way. The whole idea of hyper is that it's going to be relatively transparent to us. So most of the advice that I would give around extracts is still valid for hyper. The goal of the new engine here is to just make it work faster over bigger data. The big advantage is that it's going to query faster and it's going to load data faster. The factors that you need to consider here is that the incoming data is still the same, right? The more you pull in, the longer it's going to take. And it's going to hit your machine harder, but hopefully it'll hit it for a shorter period of time. All right, let's push down to the lowest level down here, the platform level. So this is where we're concerned with the environment, the operating system, the hardware. This is stuff to be aware of early in the cycle because it's hard to change later. So just monitor your environment. Use tools like Tabmon. This was my demo server last week, and it was running along, but one of my VizQL servers had become stuck, and so it was spinning. So we needed to fix that. You know, get your data in the right place. Test both remotely and locally in here. Keep upgrading. Upgrade your software, the latest version. We're constantly fixing bugs. We're constantly fine-tuning the product. So continue to upgrade the product. You've got to keep them separated. So your VizQLs and your backgrounders. Your backgrounders can be very, very aggressive for resources. So if you are running extract refreshes during the course of the day, think about having a dedicated backgrounder node, so you keep that separated away from the interactive users. Just be aware of physical versus virtual. So if you're running on a virtualized stack, probably the most important thing here is to just make sure that you are running on dedicated RAM and dedicated CPU. Tableau is very latency sensitive, and so if you find yourself in situations where you are that the application is held up waiting for resources to be freed by another guest on the virtual stack, you can start to have really funky problems coming through. So, right back at the start, my too long didn't read was probably too long and you didn't read it. So, there's lots of reasons for slow performance. Every situation is unique. You have to investigate it separately. There'll be a bunch of options that you could be presented with. You need to look at all of them because there is no silver bullet, and it could be in one environment that this solves your problem, and in another environment it could be something else. You saw that diagram right back at the beginning. The bottleneck can come from anywhere, so you need to try and work out where to focus your time and attention. All of this is recommendations. You don't have to do all of this stuff. You don't have to do a lot of this stuff when you're working on little data, but practice makes perfect for when you transition onto big data in here. So that's the end of the presentation. If you enjoyed it so much you wanted to come and see me do it again, there's a repeat on tomorrow afternoon, or if you wanted to recommend it to anybody else, this is the time. There's a whole bunch of other sessions that are related to this topic in here. Basically, go into the schedule and search for efficient or performance, and you'll find a whole bunch of things in here. So that's it. Thanks for coming along. I hope it was informative. Please fill out the survey. Thanks very much.